Today, I'm going to be talking about a role that experimental philosophy might be able to play for conceptual engineering. I've spent a lot of time defending and elaborating conceptual engineering approaches. I'm also working on a experimental philosophy project with respect to truth right now for the RK Philosophical Research Center. And I gave a talk on X-Fi associated with truth a bit ago, and during that talk, Mark Pinder asked a really interesting question and had a really nice challenge for the approach that I was presenting. And Mark's been a great interlocutor for a long time. I've had him out at the RK Center from time to time, and he's given talks for us in the past. And so this is a sort of development and response to some of the thinking that Mark's objection led to. And so what I'm going to do is talk a little bit about how experimental philosophy has been appealed to by conceptual engineering theorists, and what sorts of roles X-Fi has been thought to play in conceptual engineering, or might be able to play. I'm going to disagree a bit with some of what's been said and look through a couple of examples. And my conclusion is going to be that there are clear uses for experimental philosophy within some conceptual engineering projects. However, it's not going to be obviously relevant to all conceptual engineering projects. And so one of the big issues, I think, going forward is to identify which sorts of conceptual engineering projects can benefit from experimental philosophy and which ones are largely independent of experimental philosophy and the kinds of results that X-Fi might be able to deliver. So I'm going to be offering a sort of mixed conclusion here about the role X-Fi might play in conceptual engineering. So on the handout, we have experimental philosophy. It's using scientific techniques from experimental psychology and cognitive science to investigate people's reactions to philosophically significant considerations. That's just as neutral as I can be. Some X-Fi folks focus on thought experiments, others focus on principles, others focus on intuitions, and so on. There's also multiple different wings or traditions within X-Fi, and it's a thriving research area that continues to grow. And conceptual engineering is another relatively new area of philosophy, at least in the sense of contemporary philosophy. It focuses on assessing and improving our representational devices. This phrase, representational devices, is kind of come to be sort of standard now to include words and concepts and meanings. One of the things that I've been emphasizing about conceptual engineering for a long time now is that psychology and linguistics have kind of gone separate paths, and it used to be that you could that the words concept and meaning were more or less intersubstitutable in these sorts of philosophical discussions, but I want to emphasize, or at least suggest to you, that that's no longer the case, and concepts should be thought of as mental representations or mental particulars, whereas meanings should be thought of as properties of natural language expressions. There are obvious connections between meanings on the one hand and concepts on the other. For example, many concepts are lexicalized, so the concept is associated with a particular word, which then is associated with a particular meaning. Nevertheless, the thinking about meanings and the thinking about concepts from theorists in those respective disciplines has diverged. If you look at Susan Carey's spectacular book on concepts, that's a great way to get into the psychology of concepts literature. And taking a look at recent work on natural language semantics is a good way to get into recent work on meaning. So this distinction is not going to be hugely important for us today, but I do want to mark it. I do talk, I say meanings / concepts occasionally. Sometimes I use representational devices, but that's where I think that it's one of the important distinctions that I think anybody who's doing conceptual engineering ought to pay attention to. Okay, so we have two different kind of elements of conceptual engineering. One's the evaluation part, one's the change part. So the evaluation part would be identifying concepts or meanings that are problematic and in various ways. And then the change part is thinking about what kinds of changes should be made and how best to implement those changes. So for example, and I'll come back to this example in a moment, in previous work, I've suggested that the concept of truth is defective in various ways, and those defects are what leads to the liar paradox and a lot of other paradoxes associated with truth. The evaluation, therefore, is that truth's a defective concept in need of replacement for certain purposes, at least. And then the change part would be what changes should be made. I've advocated replacing the concept of truth with two concepts, ascending truth and descending truth, at least for the purposes of doing semantics for expressively rich languages. I'm not advocating this as a change for our for everybody or for even most people. Only theorists who are doing work on natural language semantics and whose semantic theories are in peril or at risk of being made inconsistent by liar type paradoxes. Those are the folks who I think ought to switch to ascending truth and descending truth for their theoretical work. Okay, so now one issue with XFI, before it can play nicely with conceptual engineering, has to do with concepts and meanings on the one hand and beliefs on the other. So this isn't a criticism of any particular approach in XFI or any particular person, but it's a rich, complicated set, literature out there, and there's lots of different ways of doing it. And one of the things that I've noticed is that there can be a tendency to assimilate any use patterns to meaning or concept patterns as opposed to belief patterns. So that's the worry here and the sort of issue that I wanted to mark. So let me say a little bit more about that. So anytime you have a conversation with somebody and someone says something that seems wrong to you, then there's, I guess, kind of two major ways that you can explain the difference. One is that the person you're talking to means what you mean by the words involved, and that person just has different beliefs. Okay, so that would be one way of making sense, is a difference in belief. Another way to make sense of the exchange would be to say that the other person means something different than what you mean by the words involved. Now, maybe they believe the same thing you do, maybe they don't, but the words that are being offered in the conversation don't mean what you're assuming they mean, and that's why they seem off to you. Okay, so this difference in belief difference versus meaning or concept difference is a crucial aspect of interpreting pretty much anybody. Many traditional philosophical methodologies focus on belief change. And the idea would be that progress in philosophy is about getting the right beliefs. We have the wrong belief, maybe the wrong epistemology or epistemological theory, and progress would be getting the right belief, getting the right theory. That's a really traditional, common way of thinking about progress in philosophy. And that focuses or puts all of the emphasis on belief differences. Now, conceptual engineering emphasizes that progress can happen with belief changes, of course, but that some progress requires meaning changes or concept changes. And so conceptual engineering does not focus exclusively on belief change. Now, it's my understanding, or my, I think, deeply held view that understanding the balance between belief change on the one hand and meaning change on the other hand for philosophical progress is the most important and most difficult aspect of doing conceptual engineering. Trying to figure out how to make these kinds of changes in the right circumstances, that's the hardest thing. Getting the belief change versus meaning change distinction right is hard. Now, if XFI is going to contribute to conceptual engineering, then it needs to emphasize this difference between belief change and meaning change as well. So it's common to identify some pattern in usage and then take that pattern to be indicative of a difference in meaning. And here I want to caution against that inference and instead say that the matter is more complicated than that. It might be a difference in meaning, but it might be a difference in belief. And there are various ways of adjudicating this matter that I'm not going to go into here, but it's the emphasis on the distinction and the subtlety of the distinction that I want to raise here. So for example, in a recent book, Semantics for Reasons, I argued that the distinction between contributory reasons and conclusive reasons is not a semantic distinction. It's best explained as a difference in beliefs. So contributory reasons are ones that are among other reasons and they haven't fought it out for who's going to win yet. And a conclusive reason is one that wins the battle or the fight with the other reasons that are in play and is the all things considered reason. So you might think that this contributory conclusive difference is a difference in meaning, but we've argued, my co-author Brian Weaver and I in Semantics for Reasons argued that that's not the case. And instead, this is best understood as a difference in belief or assumptions. So the word reason means the same thing, but the difference in the cases comes from additional assumptions, no changes in the meaning of the word reason. Okay, so I think that XFI can be done in a way that's sensitive to this distinction and this difference, and often it is. Again, I'm not calling out anybody or criticizing anyone in particular here. It's just in order for XFI to work well with conceptual engineering, this difference between meaning change and belief change has to be something at the front of people's minds who are engaged in these kinds of projects. Okay, so XFI has already been tapped to play a role in conceptual engineering by theorists like Jonas Schuppach and Joshua Shepard and James Justice, Justin Fisher and Jennifer Nato. However, they focus mostly on continuity between the old and the new. So the old way of having our representational devices and a new way of having representational devices. And the discussion so far has been mostly oriented towards Strawson's objection to conceptual engineering, which is, isn't this just changing the subject? And so a number of, the theorists that I just mentioned emphasize the role that experimental philosophy can play, or XFI can play, in overcoming Strawson's challenge. So in identifying some continuity between the old way of thinking and talking and the new way of thinking and talking. So for example, Schuppach and Shepard and Justice emphasized continuity of meaning. So the idea would be that you want your new meanings to be continuous with the old ones, or if you're doing a revision strategy, you're just changing the meaning itself. You want the new meaning to be continuous with the old one in a certain way. And if you're adding a new word or something like that, then you want that new meaning to be similar to the old meaning. Now, Jennifer Nato criticizes this approach, and she rejects their constraints on conceptual engineering from experimental philosophy. And she instead says that we should focus on continuity of function. Notice again, this is still part of the response to Strawson's challenge. So, but Nato's idea is not that the meaning needs to be similar, but rather that the XFI can tell us something about the function of the concept in the old way of doing things, and that should guide us in our search for replacements or revisions. I like what Nato says here, and I think that the criticisms she offers of the earlier theorists are good ones. However, I think that her conclusion is one that can work for a number of conceptual engineering approaches. I just don't think it works for all of them. And so today I want to talk about a couple of different examples, some where the continuity of function idea from Nato works well, and others where it doesn't work as well. Okay. So let's look at the concept of truth. So this is an example, again, that I've been pushing for quite a while now. I've suggested that we replace our concept of truth for the purposes of doing semantics for expressively rich languages. It's not all semantic theorizing, it's semantics for expressively rich languages. Those are ones that can formulate liar type objections, liar type paradoxes, in a book called Replacing Truth from a while back. The replacement concepts I've called ascending truth and descending truth. I'm currently working on a series of XFI experiments into how everyday English speakers think about truth. But my intentions for using XFI are rather different from the ones that NATO suggests. I'm not trying to identify some function of the concept of truth that then can be carried on for the replacements or serve as constraints on the replacement concepts. Instead, I think that the function of truth, and here NATO is really careful about this, and in a very solid way. Some conceptual engineering people who talk about the function of a concept think of it as this sort of intrinsic teleological aspect of the concept that's built in. NATO doesn't think that. She's very clear and careful about how she thinks that functions are just things we do with them. Not something that has to be built in or essential to the concept. So Herman Kaplan, in his book Fixing Language, criticizes this idea of functions for concepts quite a bit. But I think that NATO's view here escapes the objections that Kaplan offers, because he's mostly targeting the sort of intrinsic teleology view of what a concept's function is. But so NATO's view is weaker here than one you might expect, but the weakness of the view actually seems to me to be a problem. So, for example, for truth, the function that's relevant to the project that I've just been describing is providing semantics, in natural language semantics, so truth conditional semantics. That's one of the things that we call on truth to do. But you don't need to do XFI to figure that out. All you have to do is be familiar with the literature on truth. And you don't even need to be that familiar with the literature on truth to see that people want to use truth to do natural language semantics, or as an important explanatory device in natural language semantics. So I think this case points against NATO's conclusion. It doesn't seem like any XFI is actually needed here in order to identify the function that truth plays, the relevant function. Instead, you just need to pay attention to the literature, and then that's about it. You see that this is something that's worth doing, and then you want to try to preserve that. That's at least the way that I went on this and the way that I've been thinking about it ever since. So why am I doing XFI then with respect to truth? If I don't think that it helps us identify the function, then why do it? Now, for me, the answer is that it helps us with the identification of plausible or helpful contents or concepts. So ones that will be familiar or intuitive to people and be easier to use and learn. So back on the handout, instead, I think the result of an XFI project on truth can help us find the best replacements for truth. Other things being equal, we can we adopt concepts and meanings that'll be the most intuitive and easiest to use within the target domain. XFI can help identifying the most intuitive principles or examples in the old vocabulary. These then will be the most important items to preserve when making changes. So I'm not suggesting that the meaning needs to be preserved in the way that some of these earlier theorists did. I'm not suggesting that the function needs to be something that's identified by XFI, but instead I'm suggesting that principles, XFI can help us identify which principles we should be trying to preserve in the replacements versus which ones we might be willing to give up, at least in their pure form, in the replacements. So look at two examples here on the handout. Principle 1, if a sentence P is true, then P. So for example, if snow is white is true, then snow is white. 2, if a sentence P entails a sentence Q and P is true, then Q is true. Okay, so the former principle is one that is preserved in the replacement concepts that I've offered. It's preserved in the concept of descending truth. So it has a homogeneous replacement principle in the new scheme, 1 star. If a sentence P is descending true, then P. see there, all the occurrences of truth are replaced by a single occurrence. And so we end up with this homogeneous principle. It works for descending truth, then it's preserved there. And the familiarity associated with this principle in truth gets transferred to familiarity with descending truth. However, the latter principle, too, has no homogeneous replacement in the new scheme. Instead, the best we can do with it is a heterogeneous replacement to star. If a sentence P entails a sentence Q and P is descending true, then Q is ascending true. Notice that one occurrence of true got replaced by ascending true, and one occurrence of true got replaced by descending true. So there is no replacement concept that obeys principle 2. There just isn't one. You can get this mixed principle out of them, but there is, neither ascending truth nor descending truth obey principle 2. Now, my hope is that by emphasizing more intuitive principles like 1 over 2 in the replacement scheme, we make the replacement concepts easier to use, and easier to use, that is, by the folks who are in the target audience, the people who are supposed to be doing the thing that the new concepts were needed to do. In this case, that's semantics for expressively rich languages. All right, so if we think of conceptual engineering as having at least 3 elements, then we can see a potential role for xphi in each of them. So in the evaluation phase, right, so assessing our existing representational devices, in the suggested changes phase, that is a proposal for how to change which representational devices we use for which purposes, and in the implementation phase, a proposal for how to implement the suggested changes. So it seems to me that xphi can, and again, I mean, it plays different roles in these different phases. So I think xphi can play a role in the evaluation phase by identifying tensions and exposing flaws in our representational devices. For example, in the discussion literature on pejoratives, it's pretty common to use Bosch as an example. This is not a current pejorative, but an old pejorative. And the idea here would be something like, we could use experimental philosophy to identify introductory inferences, like from someone's German to that person's Bosch. And so those would be introduction moves and then elimination moves as well. So if someone's Bosch, then the person is more likely to be violent than others. So more prone to barbarism, I think, is the term that was used. So xphi could help us identify these sorts of introduction and elimination moves associated with the term, and we could then make a judgment that the term is indeed defective. It has inharmonious introduction and elimination principles as discovered by experimental philosophy. Okay, so that's a role that xphi can play just in the evaluation stage. Moreover, it also play a role in the suggested changes in the implementation phase, because if you propose changes that track the most intuitive elements of our existing representational devices, it's more likely that the changes are going to be adopted by the right people. So by having your suggested changes be ones that are influenced by experimental philosophy, it makes your implementation challenge much easier. It makes it much more likely that people will take up and utilize the concepts in question, as opposed to just ignoring them. Okay, so the truth example supports using experimental philosophy as a part of conceptual engineering projects. And so that's part of my conclusion, is that yes, xphi can be used in conceptual engineering projects, at least in certain ones. Now, maybe you think this isn't a very good example. Maybe you think it's not a good example because it involves replacement instead of revision. Remember, revision would be taking a word that has a meaning and changing that meaning around a little bit. So it's still the same meaning, but it's different in some way. Okay, that would be revision. Replacement would be introducing a different word with a different meaning, or introducing a different meaning for the same word, or introducing 2 words with 2 meanings, or whatever. So The truth case does depend on replacement instead of revision. And it takes a two concept replacement at that. So maybe you think it's not a very good example. I want to then look at a couple of other ones. One, I think a positive case where I think X5 would work well, and the other where it's not clear that it works well. So let's look at a couple of these other cases. All right, so amelioration. It's hard to characterize every way, at least the way the term is used in contemporary or current conceptual engineering literature. It's definitely has something to do with being influenced or inspired by Sally Haslinger's groundbreaking work on gender and race. Many of us are influenced and inspired by Haslinger's work, but for someone to utilize this term amelioration, typically they're involved in social justice and are focused on conceptual engineering projects that will have social justice as one of the intended outcomes. Okay, so there's an issue here because Haslinger's own work is interpretively difficult. It's difficult to interpret exactly what she's up to. And she's also changed in various ways over the years. And so I don't want to invite worries about my reading of Haslinger here. I just want to suffice to say that there is a way of interpreting her earlier work as conceptual engineering. That interpretation is somewhat threatened by what she says later on about semantic externalism and the role that it's supposed to play in this project. But it should be uncontroversial that lots of theorists have been engaging in conceptual engineering and amelioration type projects that are influenced by Sally Haslinger's work. And here I'm thinking of Catherine Jenkins and Kate Mann, who explicitly use terms like amelioration for their projects. Jenkins is associated with gender terms, and Kate Mann is associated with some other terms associated with feminism, like sexism and misogyny. So with social justice as a common goal, it would make sense for those engaged in amelioration to utilize XFI techniques, especially because the target audiences are often so large. In an amelioration case, the target audience is frequently, all the people who are, speaking this particular language. And so with a really big target audience, the implementation challenge becomes a serious issue. And so if you can use XFI to identify the most intuitive or familiar aspects of the old vocabulary or terminology that you want to preserve in the new, that can help quite a bit with respect to implementation. So I think just bare bones, full stop, that I think XFI could be used fruitfully in amelioration type projects. But I want to pause for a moment and think and invite you to think with me about a potential project here that I haven't seen before. And I guess I came up with it by thinking about the title of Sally Haslinger's early piece on gender and race. And she says, what are they and what do we want them to be? Right. So the what do we want them to be question is one where if you think of we in that question in a very broad way as all the people who are speaking the language, then it could be thought of as a sort of experimental conceptual engineering project. This isn't anything that Haslinger is engaged in as far as I know, but one can imagine a different sort of project here, which would be attempting to solicit from a wide range of English speakers, to just pick this particular case, how to change the language. So you're not having one particular theorist say, here's a suggestion for amelioration, and then it either gets implemented or it doesn't. It would rather be a sort of social project of amelioration where the amelioration itself is outsourced to a large number of people. Again, it's not a kind of project that I'm attributing to anybody, and it might end up not working out very well, but that's at least one direction that somebody might go if you're thinking of how to combine experimental philosophy and amelioration in particular. So what do we want these concepts to be, where the we is read in a very wide way? Then the techniques of experimental philosophy might be utilized to, in a very direct way. And you could call this experimental conceptual engineering. XCE is the little phrase that I came up with there for the handout. So about amelioration, it does seem like XFi could play an important role in amelioration type projects. And mostly my argument there has been that these amelioration projects have large target audiences, and so very difficult implementation challenges. And XFi can help with, if XFi can help with identifying, intuitive or familiar aspects of our representational scheme, then it might be able to help with this sort of implementation challenge. Okay, so again, this is just supporting the idea that XFi can play an important role in conceptual engineering cases. I've given you the truth case as one example, and here's the amelioration examples. And I think they both point in the same direction, which is that XFi, there's an important role for XFi to play here. Okay, now for some different data. So let's look at the planet example here. I've talked about this planet example in talks in the past, but the more I think it through, the more I kind of like it. One reason I like the planet example is that it's not a philosophy example. It's something that happened out there in the world, independent of philosophy, and it's a successful conceptual engineering example. So in 2006, the International Astronomical Union adopted a new definition for the word planet. So according to this new definition, a planet is a celestial body that is A, in orbit around the sun, B, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium. That's a fancy way of saying it's roughly spherical, and it's roughly spherical because it has enough mass to organize its own shape into something like a sphere. And C, it's cleared the neighborhood around its orbit. And it's these three necessary conditions that are proposed by the IAU in 2006 and adopted by the scientific community. One result of the new definition is that Pluto is not a planet. And the reason Pluto is not a planet is that it fails to satisfy clause C. It has not cleared the neighborhood around its orbit. So it satisfies A and B. It's in orbit around the sun. It's roughly spherical, but it has not cleared the neighborhood around its orbit, and so it doesn't count as a planet. All right, so the conceptual engineering change seems, to me at least, to go against intuitive considerations. So it seems to me like XFi considerations here would not have favored this sort of change. If you consider, just for a moment, testing clause C versus the claim that Pluto is a planet, my guess is that Pluto as a planet is going to come out vastly more intuitive than planets have cleared the neighborhood around their orbit. That is just a guess on my part. I haven't actually done the experiment, and if someone wants to do that and come up with some data that go against my hypothesis here, then I'd love to see it. But my hypothesis is, and I hope you agree with me, that for the most part, people are going to take Pluto as a planet to be vastly more intuitive than planets have cleared the neighborhood around their orbit. In fact, I mean, for almost all the planets except for Earth, the number one thing people know about them is that they're a planet, right? Mercury's a planet is probably the number one thing people know about Mercury. Pluto's a planet is probably the number one thing people know or knew about Pluto. Okay, so it seems to me that XY considerations would not support this change. This is a change that goes against the kinds of considerations I've been appealing to throughout the talk, at least in the cases of truth and in the amelioration cases. There was, in fact, a very large public backlash and outcry about this change. People were very unhappy about it. And there was even a number of, movements to get Pluto reinstated as a planet and so forth. These didn't really go anywhere. Instead, the changes have taken hold across society. Example is kids' books. Kids' books today, if you have kids and you read books to your kids and you buy a new book, then it's not going to have Pluto as a planet. This isn't a science book, it's just a popular book for kids. And even the popular books for kids follow the scientists in taking Pluto to not be a planet. If you go to the used bookstore and buy a book from 20 years ago about the solar system, then it will say that Pluto is a planet. And so this is a change that's occurred. If you're reading one of these older books to your kids, then your kids might get confused and say, well, just tell me, is Pluto a planet or not? It's not. I'm deferring to contemporary usage of planet here by saying it's not. Okay, so what's important about the planet example? So far, as I've described it, the important thing is that it's a case of conceptual engineering, but it seems like a case of conceptual engineering that goes against familiarity or intuitive considerations that I would expect experimental philosophy would be able to provide in a case like this. So this is not a case where experimental philosophy supports the change or would have supported the change. And instead, this seems like a change that goes against the kinds of considerations I've been proposing. All right, so why change planet? Why did it actually change? So here we need to do a little bit of history quickly. The history is, I'm going to be using planet double star for an earlier, much earlier meaning, and then planet star for the one that was in play up until 2006 when we changed to just planet. So there's planet bare, that means what you should mean by it, which is what we currently mean by it, according to which Pluto is not a planet. Then there's planet star, which is the old meaning, and then planet double star is the ancient meaning. Okay, so first there were 5 planets double star. So these would be wanderers in the sky on a geocentric model of the solar system. So you have the Earth in the center and everything else goes around the Earth. So if you think about the solar system in that way, then there's only, and you only pay attention to what you can see in the sky, then there's only 5 planets. Then once we make the switch from a geocentric model to a heliocentric model, roughly around the time of the scientific revolution, then there's 6 planets. Earth gets added to the list as one of the planets. Okay, so we've switched then from the old meaning, planet double star, to the intermediate meaning, planet star here, with this switch from the geocentric to the heliocentric model. Okay, so the idea that Earth is a planet was a revolutionary idea. It seems really obvious to us now, but that was a big deal at the time. And I'm suggesting that that was such a big change, or a change of the right kind to be classified as a meaning or a concept change. Okay, so then after that, using telescopes, people identified 7, 8, and 9 planets. And then, of course, there were other kinds of worries, like asteroids. Do asteroids count as planets? Ceres was discovered, fairly early on, and caused some problems. But eventually, people didn't worry that much about it. And said, well, we can just have the asteroids be the stuff that's in between Jupiter and Mars, and then that'll work out okay. And then we can just keep planet. But then more recently, in the early 2000s, a number of discoveries occurred, and scientists became pretty convinced that there were going to be lots and lots of things that would classify as planets. So lots of the new ones, so like asteroids, Ceres in particular, and Kuiper belt objects, which are the ones that were discovered in the early 2000s, those were similar in size to our familiar planets, but not quite like the familiar planets because of clause C. The ones that don't seem like planets are ones that have not cleared the neighborhood around their orbit. Ceres, for example, is sitting right in the middle of the asteroid belt. It hasn't cleared the neighborhood around its orbit. Pluto hasn't cleared the neighborhood around its orbit. And many of the Kuiper belt objects, which are out further than Pluto, are in the same category. So scientists, so the upshot here is that scientists discovered that there's really two populations that are relevant here. There's 8 planets, which make up one natural population, and then there's a whole lot of dwarf planets. And the dwarf planets are ones that are not satellites of some other object going around the sun. So they're going around, they're orbiting the sun directly. And they fail clause C. They have not cleared the neighborhood around their orbit. So in retrospect, Pluto, what was discovered when Pluto was discovered was not a planet, but a dwarf planet. And so that's the sort of short history for why we made the change, why the scientists decided to make the change. The scientists decided to make the change because they discovered that there's really 2 underlying populations here, not just one. We thought there was one thing, planets, but really there's 2 different kinds of things, planets and dwarf planets. And the difference between them is a natural difference. So this sort of change has a lot more to do with naturalness and fundamentality than it does preserving some familiar element in our talking and thinking. So that's one of the reasons why I like the planet example, at least in the discussion of experimental philosophy and conceptual engineering, is that it seems to go against the idea that experimental philosophy can help us in conceptual engineering. It's not obvious that experimental philosophy would be able to help us in any way with respect to this kind of change. Now, I want to just draw one connection here between this sort of change, the planet example, and something that is happening in philosophy, and that would be work that's being done in contemporary analytic metaphysics and on the existential quantifier. So I'm thinking in particular of work by Ted Sider and what he calls Plan B in his book, Writing the Book of the World. So Sider thinks that the existential quantifier of English is fundamental, is natural in the important sense that he defines. He doesn't use the term natural, but that's okay. It's a successor to naturalness. Okay, so so he thinks that the existential quantifier is fundamental, but he also admits that he might be wrong about this, and if he is wrong about it, then he wants metaphysicians who are following in the kind of project that he's advocating to have a plan B. The plan B is what to do in case the existential quantifier turns out to be not fundamental. And so plan B would be switch the language. Just introduce an existential quantifier that's stipulated to be fundamental and use that in theorizing. So some folks have taken to calling the imagined change ontologies, and occasionally you'll hear or you'll read of people talking in the ontology room or in the metaphysics room, and that's the sort of change that I have in mind here. Now, there's all sorts of discussions about quantifier variance and whether this is a legitimate disagreement, or whether people who are just arguing about the existential quantifier are just talking past one another. I'm not going to get into that, but the only thing that I want to point out here is that the planet case of conceptual engineering seems a lot like, or a lot more like, the case of the existential quantifier in contemporary analytic metaphysics, the Plan B, Sider's Plan B project, than it does the other ones that I've mentioned here. And again, the Sider Plan B project probably wouldn't have much use for experimental philosophy either. It doesn't seem like XFI would have much to say for Sider's Plan B type project, just like it wouldn't have much to say for the astronomers project of redefining planet. Okay, so the upshot here, the conclusions. Conclusions one, there are important roles for experimental philosophy within conceptual engineering projects, but the kind and extent of the role for experimental philosophy is probably going to depend on the kind of conceptual engineering project. Some conceptual engineering projects really could use XFI as something that will benefit them. Whereas other kinds of conceptual engineering projects, for other ones, it seems like XFI is not relevant to the conceptual engineering project. So I've given you Truth, a project that I'm engaged in, as an example of one where XFI seems to be relevant and seems like it can help. I've also encouraged you to think that amelioration projects within conceptual engineering are ones where experimental philosophy might be able to play a helpful role. But I've also argued that cases like Planet, those are ones where XFI wouldn't really play much of a role. And so I want to get across that there's a wide range of different conceptual engineering projects out there, and it seems like XFI could be helpful for some of them, but not for others. So what's the difference between them? It seems to me, just on the sort of, scratching the surface, level of detail here, that preserving existing intuitions, if that's important in the conceptual engineering project, the more important that is, the more XFI can help. And if that's not an important element of a conceptual engineering project, in the Planet case, the scientists weren't really interested in trying to make us feel comfy and familiar and intuitively satisfied with the result. Rather, they were making changes that would be helpful for doing science. And those changes, although they did affect all of us who are English speakers, by making Planet take on a different meaning, they weren't intended for us. These are changes that were intended for the scientists. Okay, so it seems like XFI can play a role. It's not obvious to me which of the conceptual engineering projects are the ones where XFI is the most relevant, but I'm taking a stab at this and suggesting that if preserving intuitions is an important element of a conceptual engineering project, then XFI can help. And the more preserving intuitions is an important thing for your conceptual engineering project, the more XFI can help out. So then it does seem to me then that NATO's suggestion is one that might work out. It might very well be that XFI can help us in understanding the function of a concept or a meaning, and that would help in various conceptual engineering projects. But at least in the Truth project, given what NATO means by function, we didn't really need XFI to identify the function in that case. And so I'm happy to think of other, or to be reminded of other cases where XFI could help us in the way that NATO suggests. I'm not thinking that that there are no potential cases like that, but I am saying that not all of them are like that. I don't think that the Truth case is like that, and the Planet case seems to me to be one where preserving the function just wasn't a part of the project at all. that there is no preserving the function element in the planet case. There is the preserving the function element in the truth case that I described. And that's one reason that, I think that there's, something to what NATO is up to. But if she's right about this, then it seems to me at least that she's probably right about a limited number of conceptual engineering projects rather than conceptual engineering in general. So just to wrap up, the talk is mostly been about where and how XFi can play a role in conceptual engineering projects. And I've suggested that it can play some role, and I've given you some examples in which it will, or could, or should play a role. But there are also examples like the planet example, which don't seem to support XFi, don't seem to have a role for XFi at all. And these are successful, this is a successful conceptual engineering project here. So going forward, I would think that there's a lot more that needs to be done in thinking about this topic. I would hope that as we, as a group, think more about this issue, we'll detach from thinking about only the Strawson challenge, only thinking about Strawson's challenge as the natural home for this topic, and instead branch out into a wider range of different hypotheses about the role that XFi can play in CE, because so far most of the suggestions have been focused on solving Strawson's challenge. And I don't take Strawson's challenge to be one of the really major issues for conceptual engineering, and so I'm suggesting that we can broaden this discussion in various ways going forward. All right, that's it. Thanks so much. I really appreciate you hanging out for the talk.